Hey everybody, Cheng is here. As I promised in last video, I gonna walk through the code in depth. I know some of you guys are starting projects, so I'll try to cover as in detail as possible. But still, if you have any questions or anything I missed, feel free to leave a comment below. I'll make sure to reply every single one of them. So in a typical Arduino program, you always include whatever libraries you're going to use. Here we're using the servo.h library. We're not looking into that, but basically it's a file that include all the servo related functions and definitions and everything. So it's just a different file that you can refer to and clean up your code with this single line. And you can refer to everything inside it later in your code. Then coming next are all those definitions. Basically, you define, take this for example, you define the trigger pin as A0. So this could be whatever you want. You can name it whatever. Just make sure it makes sense in a way that you can understand what it is about. And you can connect basically this name and one of the pin on the Arduino. So I'm defining A0 as a trigger pin. I'm defining echo pin as a one, and so on and so forth, such as these guys. These are all for the L298Ns. So as you know, there are the enable A, enable B, and four of the input pins. And here I'm just using the digital pins, so you don't have to put an A in front of it. It is the analog pins, and here are just digital. You don't need a D or anything. And we can define the servo pin here, number 2. Okay. Coming next, I think this probably is a little advanced. All this chunk here. Uh, this would be something that looks like in servo.h library. I was just to, I think since this motor library is so simple, we can just put it in here, so you don't have to worry about the, installing all the different libraries and mess up all the file and whatever. So just to make it clear, this in the best practice, it should be a different .h file, but here it's just cleaner from a file management standpoint. But also you can look into how I handle classes in this program. So Arduino is the C++ language, and it's an object-oriented programming. So you can define different classes. A good example for class is like students, right? You have like 15 students in your class, and you can define what's a property of a student. For example, they all have a gender, they all have a name, they all have an age, they maybe have a different score whatsoever. So you can define their properties in this class, and you can instantiate, which means create a new student. So you can put all the different, maybe the first student is called John, 15 years old, the other is married, 16 years old, so on and so forth. So here I'm just defining the class motor. It has 3 properties. One is enable pin, direction pin 1, and direction pin 2, which are the 2 of the input pins for a certain motor. And I also, in class, you can give the class some functions like actions, what they can do. So in that student example, they can speak up in class, they can finish the homework, so on and so forth. So here I defined 2 public methods or functions. This first one is the motor. This basically instantiate one motor. So you can see this is the name of a function, and these are the arguments or parameters that you need to put into it. So I'm basically seeing here the property of the motor gonna be this guy, whatever I gonna put in this blank, the direction and direction. So they are gonna match. So basically writing a line of this with 3 parameters, meaning I gonna create a new motor, and in the new motor, this would be the enable pin, this would be the direction pin 1 and direction pin 2. And the next one is the method for make the motor drive. So in here, I want to simplify the driving code, right? If you just use the L298, then it will be pretty complicated. You have to be I want to enable pin A to be high, then you have to input pin 1 high, input pin 2 low, or reversing everything, or so it's quite complicated. I mean, it's gonna be a lot of replication in your code. So this could simplify it. What is here is you just need one parameter as speed, and this is an integer, and but it's should be through from 0 to 255 because that's how much the PWM gonna take. So if the speed is uh, greater than 0, you're gonna write the digital pin 1 and pin 2 accordingly, meaning the direction of the motor. If it's smaller than 0 or less than 0, it will reverse that and reverse the speed. And since we're passing one integer, it could be a negative number. Yeah, actually correct. Yeah, here. If it's -1 to -255, it needs to reverse, right? But you are already done here, meaning change the direction to reverse. So the speed need to be uh, negative of that. So the motor still drives because the PWM only supports 0 to 255. It doesn't take anything negative. So this would be correcting that. And once everything's figured out, it will analog write the enable pin with that speed. Yeah. So that's, again, everything here is defining the motor class. It have the properties, it have the method to define the motor, and have the method to make it drive. So here, the next two line would be instantiate the two motors. I want the left motor equals to this new motor, and the motor would have the ENA and 1 and N2, which gonna equal to these guys that pass inside of it. And also notice these are actually the pins we defined earlier here. Same as right motor. And this also is the way to create a servo. So you can see that is a different color. I think that's how our Arduino IDE handles the libraries. If I create a motor library, I think you'll have the same treatment here. So servo, my servo, then yeah, I didn't look into what's that about, but yeah, it's all in that class. Then we create this method to initiate the motors. Basically, give it an initial speed and direction, and also initiate all the pins, right? So make sure all the pins connect to L298N are outputs, and also give them the directions and also the speed. So in the beginning, the speed are all low, which is 0, meaning nothing gonna run. And also all the directions are forward. Okay. Next section, we're defining the variables. Here, most of them are the variables for the ultrasonic sensor. So this line is ultrasonic sensor. This 2 is what I created. So this is a Boolean variable called obstacle head, meaning if it sees anything or not. So initially it's false. And here integer of servo position. So since the servo can turn through 0 degrees to 180, by passing 90, it's straight ahead. And here, enum directions. This is something I just learned not long ago. I feel hard to explain what enum is, but my understanding is this basically you're defining your own data type. So for example, if it's a Boolean type, it only has two values, right? One is true, the other is false. But for enum, you can define what values it can be. So basically, I define something called directions, and the directions could be one of these 5 guys: forward, turn left, turn right, turn around, and brake. So I can refer to this easier later. I mean, you can define something like directions with a number, but you'll just have to remember which number equals to what direction. So this is just make it easier to read. And here directions next step. So here I'm already referring the directions, right? Just like the int or boolean. Here directions, I'm referring to this directions data type. And this new variable next step, which is the directions type, equals to forward. That's the initial state. And this next step can only be any of these. And here T1, T2, pulse width, cm, and inches are all the ultrasonic sensor stuff. So in voice setup, here are some copied from the ultrasonic sensor code. So you are basically defining the pin output and also the low. These are still basically initialization, and also serial begin. That's a typical code for you to initiate the serial monitor. And my servo attach servo pin, which we defined in the beginning. Servo pin equals to, where it is, 2, right? So this is how the servo library handles attachment. So not attachment, like initiate it. So earlier it created a servo called my servo, and now it attached the servo pin to my servo, so that finished the initialization. Then I called this motor initiation that are gonna run all these guys, basically the pin mode and the initial direction and speed, and also give it direction next step just to make sure. Yeah, is it? Yeah, I think it might be duplicated, but whatever. Okay. And now we are at this void loop. And you can see it's very simple, right? Void loop are the codes that play over and over again until the end of the time or the die of the battery. But here, basically, the logic is really straightforward. It's checking the distance first, then check the directions, then drive. So check distance is trying to see if anything is in front. Then if there is, it will do the check directions to say rotate the ultrasonic sensor or the servo to see around, and then it will drive. So let's see what's under each of them. So let's look at this check distance function. It actually was pretty confusing to me. All this code doesn't really make sense until I read the data sheet. So here, to make this sensor work, you have to follow the instruction, right? So here is a data sheet, and it defines all the parameters. And also what's really important here is this timing diagram. So basically, whenever you send the trigger pin 10 microseconds high and lower it down, you're gonna initiate the sonics, supersonic bursts, which are 8 cycles of sonics bursts. And you will get the return signal or return of this sonic bursts, and know the distance, know the time by how long this ICO pin lasts. So if this is shorter, meaning it got the reflection back really fast, so the distance is smaller. If this is longer, it will be far away. And in the data sheet, it is show this formula here. The US, I think it's the time of this ICO pin divided by 58. That will be the centimeters, or 148 will be inches. Or you could do the high level time multiplied by the velocity of the sound, then divide by 2, because it's 2 ways of the ultrasonic, right? When we go and reflect back. And it also suggests this 60 milliseconds of a delay between measuring cycles. So now we can come back to the code. That should make sense now. So here it's putting the trigger pin high and delay for 10 microseconds and put it down low, which created this. Then the sensor gonna send out the sonic bursts. And before here, it says while digital read echo pin equals to 0. So during this time, it will do nothing, basically, until it received something that's the beginning of this echo pin signal. I think this is timed internally. I don't know how exactly it did it, but this is gonna start anyway at this point. So this is basically waiting for that. Then it write down T1, which is a micros, which is the current time since the Arduino start running. It will take the timestamp of this point. Then while digital read echo pin equals to 1, which is this time, so during this time, nothing gonna happen because it's just waiting to see how long it takes and when it ends. And when it jumps to 0, which is here, then the code gonna proceed to this T2, which T2 equals to the new timestamp, which is when the receiving signal is finished. So now you have the beginning time T1 here and the finish time T2 here. And minus that, you got this pulse width, which you can calculate based on the formula right here. And with that figured out, the original code have this max distance, so it will display out of range. But all these are commented out. But if you want to read it, yeah, feel free to delete these slashes and delay a 60 microseconds to wait for a next measurement. What I added onto this function is checking if the obstacle is too close. Here, this is a arbitrary number, 20 centimeters. You can tweak it to make sure it runs smoothly. So if there's something in 20 centimeters, it will give the variable obstacle ahead a true value, meaning, hey, there's something in front of it. Then this is just for debugging. I'll print through a serial saying problem ahead or obstacle ahead, whatever. And else, if there are something further than the 20 centimeters, it will just be nothing in front. Okay, let's check distance. Now let's look at this check directions. So what this function does is it checks the left and right if there's something in the front. So this also for debugging, it just tells me it's currently checking the directions. So the servo with the ultrasonic sensor should face to front in the beginning. So if there's something ahead in 20 centimeters, it give it a next step break, meaning I want it to stop, and the drive function basically executed that. Here, this is just telling the machine what's next step, and here is actually executing it. Then I'm turning my servo to right 180, which is the left side, furthest left. Then give it a delay of 400 microseconds. That is just to wait for the servo to turn. If you give it too little time, it's just don't have enough time to turn to all this 90 degrees. And I'm gonna run the check distance again, making sure nothing is on the left. If nothing is on the left, meaning it's you can turn left. So the next step become turn left. And here also a debugging line. Then this is to reset the servo position to facing front of the car. Then this is paired with that to make sure the servo returns. Feel free to adjust these numbers, but I feel like 400 is pretty good. So that's a case if there's something ahead, right? And under it, if also the left there's nothing on the left. This else, if left is blocked, then you need to look at the right. So my servo write to 0, and you can see the delay time is doubled from 400 to 800. It's just because this was moving from 90 to 180, 90 degrees. This is moving from 180 to 0, which is 180 degrees. You need more time to turn all those degrees. And yeah, this is something bug in the comment. And it check the distance to see what's ever in the right position. And if nothing's on the right, the next step become turn right. Then it also resets the servo. This else, if the right is blocked as well, then it need to turn around, which gonna be the next step, and the servo need to return as well. I think there are some formatting issue. I'll just correct it really quick. So yeah. And in the end, there is else next step equals to forward, which is nothing in the front. So let's make sure everything's making sense. If there's something in the front, it will do something, check the left. Check the left. If nothing is left, it will turn left. Else, if there's something left, it's gonna turn to right. See if anything is on the right. If nothing on the right, it will turn to right. And if there's something on the right, again, it will turn around. And in the case where nothing is in front, it will just keep going forward. So here, this else is pairing with the first if, and this is pairing on the left check. This is the right check. Okay. Now the last one is the drive function. So here I wrote a switch. Yeah, some formatting issue. So basically, a switch function is you can define all these different cases, and depends on what case you can run different code for it. So right here, I'm switching the next step, the variable here. Basically, that means I gonna have the cases based on the next step. So here, you can start from the top. If the next step equals to forward, both left and right motors gonna drive full speed to forward. And that's for debugging. And brake is just something that you need for all of the different cases. If it's turn left motor need to go backward and right motor go forward. Yeah, same as turning right. And last one is turn around. If it's turning around, so here I'm defining it to turn right and also give it a much longer delay. So it not only turns 90 degrees, but more like 180. So the speed and the time is the parameters you can tweak with. You can make it turn only 30 degrees to the left or to the right. You know, it's totally up to you. Last one is the case brake, basically gonna stop the motors, just drive at a 0 speed. Yeah, so that's basically all the codes. Let me know if you have any questions, and make sure to hit that subscribe button for future tutorials. Hope to see you soon. Out of my way, go. It's